Welcome back. In the last section, we studied the linear algebra using metric to represent data and the related operations to finish the applications. So following, we will go through the probability and statistics. It is the science to collect, analyze, interpret, and predict the data with uncertainty. Following this structure, we will go through the basic concepts first: random variable and the probability distribution, law of large numbers, and law of central limit, the parameter estimation, and hypothesis test. To begin with, we should determine the scope before we analyze the data. The population is the set of the entire dataset, and the sample is the subset of the population. For example, the blood pressure readings of all people in China is the population, and blood pressure readings of 1,000 randomly selected people in China is the sample. Actually, it is difficult to obtain information about the whole population in most cases. That's why we rely on samples to make estimations and inferences related to the whole population. And the following is the difference between the parameters and statistics. A parameter is a number that describes a population. A statistic is a number that describes a sample. Parameters are usually denoted using Greek letters, while statistics are usually denoted using the Roman letters. The population mean is a common parameter. A parameter is a fixed unknown number. A statistic is a variable. Statistic value varies from sample to sample. To estimate population parameters in inferential statistics, we could use sample statistics. For example, if we collect a random sample of children in China and measure their weights, we can calculate the sample mean. We can use the sample mean as an unbiased estimator of the population mean. Here is the descriptive statistics. The purpose of descriptive statistics is to facilitate the presentation and interpretation of the data. A variety of numerical measures are used to summarize the data in terms of location, like the media mode, the measure of the spread standard deviation, IQL, and some other methods. So we will check it one by one. The measure of the location is the primary numerical measure for quantitative data. Consider there are n samples over here, the subset of the population, to make the statements about a population. The sample mean x bar, often called the average, is computed by adding all the data values for a variable and dividing the sum by the number of the data values. The mean is a measure of the central location for the data. The sample media is another measure of a central location that, unlike the mean, is not affected by extremely large or extremely small data values. When determining the media, the data values are first ranked in order from the smallest value to the largest value. If there is an odd number of data, the media is the middle value. For example, if we have like 5 values in total, then the media is the third value. If there is an even number of data, the median is the average of the 2 middle values. The last measure of the central tendency is the mode, the data value that occurs with the greatest frequency. Here comes one question. probably most of you wonder, since the median and the mean measures the central location. Which one is better? For symmetric data, the mean is usually less variable from sample to sample than the median. For skewed data, the median is for better to ignore some outliers. The outliers are what we call the one or more values that appear unusually large or small and out of place when compared with the other data values. It concluded that the median doesn't react as much as the mean by outliers. Since the outliers are in both ends in descending or ascending order. This probability of the median is known as robustness, which is resistant to errors in the result. The mean is easier to compute than the median and is much easier to handle theoretically. Apart from the measure of location, here we have the measure of the spread, the standard deviation, or variance measures how we spread out the data around the mean. In other words, the range between the largest value and smallest value can measure the variability of the data. From the first equation, the deviation difference of each data value from the sample mean is computed and squared. The squared deviation are then summed and divided by n to provide the population variance. The standard deviation is the square root of the variance. It is noted that the sample standard deviation is a little different since it is divided by the n-1. As an unbiased estimator of the population standard deviation, IQL, the interquartile range, also indicates how the data spread. Quartiles divide the ordered dataset into 4 equal parts. The first quartile is denoted as the 25th percentile. The second part is the half percentile, also the median. The last one is Q3, which is the 75th percentile. And the IQR is the difference between the Q3 and Q1. The formula for the IQR is Q3 minus Q1. So let's compare the standard deviation and IQR. Which one is better to measure the spread? Similar to median versus mean, the IQR is robust. Like the median, but theoretically it is harder to handle than the standard deviation. Above are the typical statistic part to interpret the data itself. However, to do the prediction based on the historical data, probability is also needed to deal with uncertainty. Probability could be thought of as a numerical measure of the likelihood that a particular event will occur. Here, we have some basic concepts. Oftentimes, the reasonable probabilities can be got from the random experiment. It can be repeated under the same conditions with more than one possible outcome. And the outcome of each trial cannot be predicted with certainty. Here, we define what the sample space F is. It is the set of all the possible outcomes of a random experiment. The sample point is each possible outcome. Random event A is the subset of sample space S. We have an example rolling the dice. Since the dice has 6 faces, for any roll, there are 6 possible outcomes. And there are 6 sample points, 1, 2, 3, 4, 5, 6. In this case, we could learn that the dice probability is the chance of getting a specific number with one dice. And if the random event is the outcome is 5, the probability equals to the number of ways it can be divided by the total possible outcomes. So we can get the 1 in 6. Here we learn about conditional probability and Bayes' theorem. PYX denotes the conditional probability. It's the probability of one event Y given the occurrence of another event X, often described in terms of events X and Y from two dependent random variables. The conditional probability can be calculated using the joint probability, PYX. It is the probability of two simultaneous events. And the Bayes' theorem is the principal way of calculating a conditional probability without joint probability. This gives a formula of Bayes' theorem. PXY indicates the posterior, PYX indicates likelihood, PX indicates the prior, PY indicates the normalizer. In the real case, we could use this formula. Suppose we need to calculate the hypothesis given the whole data. According to the Bayes' theorem, we could calculate the probability of data based on the hypothesis and probability of the hypothesis, all over divided by the probability of data. Oftentimes, the probability of the data is constant, since the given data is unchanged. Here we have the total probability theorem in the probability space of n independent events. We need to sum up all the probability together. It can be used in statistical machine translation and some other scenarios. Independence is the fundamental notion in probability and statistics. Two events are independent if the occurrence of one event doesn't affect the probability of occurrence of another event. Then we have the following formulations to get the joint probability and conditional probability. PYX equals PY times PX. The probability of Y given X equals to PY.